Okay, this is the continuation of the first part. This is now calculating diagonal distances. The distance between any 2 points. So this time it's if there are any 2 points rather than having them at the same height or the same x coordinate, the same y coordinate. This time any 2 points. So any 2 points, point A, x1, y1. Those little ones indicate that they are different from these two, x2, y2. Although this could also be applied to what we just did, but it's a lot easier counting if they are on the same x coordinate or the same y coordinate. Anyway, the distance formula is given as distance equals x2 minus x1 all squared plus y2 minus y1 all squared. You add these two first and then you square root the answer that you get. So let's do an example here. So we have 2 points, any 2 points, and this time it's a diagonal distance. So we can't just count these. First we'll find the coordinates of this. Just clearly looking, it's 1, 1, 1, 1, and the coordinates for this is 5, 4. That's 5, 4. And what I do is just I label pretty much this one, the leftmost, x1, y1, and this one, x2, y2. And I just use my formula. So we'll write it as distance is equal to, I actually don't draw the square root first, I do that last. So x1 is going to be 1, sorry, x2 is 5 minus 1 squared plus y2, which is 4 minus 1 all squared, and then I square root everything. At this point you can just type this into your calculator, make sure you get everything right, but I like doing it by hand for as long as I can. So this is 5 minus 1 is 4 squared plus 4 minus 1 is 3 squared all square root. That gives me 16 plus 9, square root still there. That's square root of 25, which gives me a distance of 5 units. In this example, we're down to a nice whole number, but these normally aren't whole numbers. Some students may also be wondering why it's not plus and minus 5. Okay, because when we are dealing with measurements such as distance, height, or time, there is no such thing as negative distance. So in this example, we only take the positive values of our answer. Okay, so let me rub that one out. So let's do another example here. Let's take a look at these two at the bottom. Let's calculate distance AB first. AB. So let's find the coordinates of A. It's negative 3, 2. And B has the coordinates of, from the looks of it, 4, 8. I'll just label my points. My leftmost, this is x1, that's y1. This one is x2, y2. And just so that I can remember it, I'm gonna write it again here. So let's see, just so that you can remember as well. Distance is equal to x2 minus x1 squared plus y2 minus y1 squared all square root. So let's find out now. x2 is 4 minus -3. Here's where it gets a little tricky, because you have to substitute -3. So it's going to be 4 minus -3 all squared plus y2 is 8 minus 2 squared, and we're going to square root everything here. For the sake of time, I'm just going to use my calculator for this one. Here we go. Square root, open bracket, 4 minus -3 squared plus, open bracket, 8 minus 2 squared. Ooh. What went wrong? Oh, I need a bracket here. There we go. Boom. Square root of 85, changing it to a decimal, we get, this will give me 9.22. I like rounding off to the second decimal place. We have to round up units, and we'll just say this is 2 decimal place values. Okay, let's move on to the example here. CD, this time they're all negative distances. Let's take a look. This one here is -6. I think I was supposed to make that 2. Let's just make that -6, -2. And this one here is -3, -5. There we are. So let's find the distance of CD. Now, just to prove to you that we can actually switch x1 and y1 around, I'll make this one here x1, that one y1, and I'll make this one x2 and that one y2. Okay. So using our formula, x2 -6 minus -3 all squared plus -2 minus there -5 all squared. We're going to square root this entire value. For the sake of time, let's use our calculator. Square root, open bracket, -6 minus -3 all squared plus -2 minus -5 all squared. And we get equals to 4.24 units. And that's 2 decimal places. Two more examples for us here. This time they are not with a graph. We're just given 2 coordinates in each example, and it doesn't change a thing. So I'm going to quickly rush through this one, just so you can see the process. Oops, that's 1. And that's y2. And let's calculate the points of EF. -3 minus -5 squared. -3 minus -5 plus 4 minus x2 minus x1 minus x2, which is 6 squared, all square roots. We have here square root -3 minus -5 squared plus 4 minus 6 squared gives me 2.83 units. And that's two decimal places. And one last one. We'll make this one x2 and this one y2. Let's make this one x1 and this one y1. Using our distance GH, the distance of GH is given as x2, which is 2, minus x1 minus 1 squared plus 5y1 minus 1, which is y2, all squared, and square root everything. Using our trusted calculator, here we go. Oops. 2 minus 1 squared plus 5 minus 1 squared. Whoops, didn't see that. Gives me 6.71. 6.71 units to, whoops, 2 decimal places. This here is how we calculate distance between 2 points.